Today's topic is AC circuits, in which we will discuss the basics of the AC circuit. First, we will discuss how equation of voltage and current is being developed. Let us consider a coil having n turns, and this coil is rotated with the angular velocity of omega radians per second. At a constant speed. Let's from the movement from OX axis, it is being moved by an angle of theta, and this angle theta may be represented by omega into t. This is the maximum flux. In this constant flux, this coil is rotated. Let n be the number of turns in the coil. As per Faraday's law of electromagnetic induction, what is Faraday's first law? First law is whenever magnetic flux linking a coil changes, EMF will induce. And second law gives the magnitude of the EMF. And that is EMF induced is directly proportional to rate of change of magnetic flux linkage. Or n d phi by dt. This minus sign indicates the direction of the induced EMF, which is given by Lenz's law. And what it indicates? The EMF will induce in such a direction that it will oppose the charge produced. That it will oppose if it is induced due to the anticlockwise movement, it will oppose this anticlockwise movement. If we rotate this coil in clockwise movement, it will oppose the clockwise movement. So let us, what would be the induced EMF? Let this be the flux. This angle would also be theta. The flux perpendicular to the coil would be responsible to inducing the EMF in the coil. And that will phi m cos of theta. Now we know EMF induced is n d phi by dt. And what is n phi? Here flux is, which is responsible for inducing the EMF, is phi m cos of theta. Or flux responsible for inducing EMF may be represented by as n be the number of turns, n phi cos of theta, phi m. Now, what would be the induced EMF? Minus n phi m cos of theta and d by dt. This phi cos of theta, or minus n phi m d by dt of cos of omega t, because this theta is omega into t. T is the time in which it is rotated by an angle of theta, and omega is the angular velocity, and this time period is in seconds. Or minus n phi m, differentiation of cos theta is sin omega t, or n phi m sin of omega t. This E will be E maximum when sin of omega t is 1. Means Let me speak equation number 1. When we put the value of sine of omega t 1, what happens? Em would be n phi n omega. This phi m is Bm A, where Bm is the magnetic field density, A be the cross sectional area of the conductor, and this angular velocity may be represented by 2 pi f, where f is the frequency which is in hertz. Therefore, E would be Em sine of omega t. So whenever a conductor is rotated in a magnetic field, the equation for alternating voltage is given by Em sine of omega t. And when we represent the wave shape of this voltage, we will observe that it would have this wave shape. At 0, value is 0. At 90, maximum 0, negative maximum, and 0. Now, when this voltage is applied to a pure resistance, or when this alternating voltage is applied to a pure resistance, then I current would flow. And this current I is given by E by R and Em by R sine of omega t. So this I would be I maximum when sine of omega t is 1. So therefore Im is Em by R and I would be I maximum sine of omega t. So this will be the equation for current. And similarly, this current is also of the alternating nature. So in AC circuit, when this coil is rotated in a constant magnetic field, the EMF induced and current would be of alternating nature. Now we have some few terms which are being used in this chapter of AC circuits. First one is cycle. Cycle is a one complete set of positive and negative in an alternating quantity. It may be E or V. This E may be also represented by V. So this is a one cycle. Another term is time period. You have already studied, denoted by T. Time taken to complete one cycle is time period, and that is in seconds. So means time period is time taken to complete one cycle. each time period. Next is another term is frequency, denoted by F. Frequency is time taken to complete one cycle. Sorry, number of cycles per second, its frequency, or you can represent it F is 1 by T, and unit is hertz, time is in seconds. Another term is instantaneous value. Denoted by your current, denoted by I, voltage V, or small. Value of alternating quantity at any instant is known as instantaneous. Here the value of the alternating quantity is this one. Here value of the alternating quantity is the maximum. Here value of the alternating quantity is 0. So this is the instantaneous value of alternating quantity at a particular instant. Another term is amplitude or maximum value. That is generally represented by voltage EM or VM, current I, and maximum value is maximum magnitude attained by an alternating quantity in either direction, positive cycle or negative half cycle, is known as maximum value or amplitude of the particular alternating quantity. Another term is root mean square value. This is the important one because all the alternating quantities in our electrical engineering are measured in terms of their RMS value, root mean square value. All the voltmeters, ammeters measures these quantities, our voltage and currents, in terms of their RMS value. That's why our electrical quantities are defined in terms of RMS values. When it is not mentioned, for example, our lamp is specified or specifications are given 250 volt, 50 hertz. It means 250 volt is the RMS. If in a problem they defines that maximum value is this, it means it is maximum value. If it defines a voltage of 250 volt or 230 volt or 200 volt, means this is the RMS value. It need not to designate this is the RMS value. So what is the RMS value? RMS value is basically a steady state current or DC current which produces same amount of heat in a given resistance in a given time as produced by AC. For example, time is t, so heat produced is I square RT. Here heat produced is, so this is the steady state value which produces the same amount of heat as produced by the CC. Then that quantity value would be the RMS value, root means square value of the alternating. How it names comes, root means square. Let us consider a non-sinusoidal wave shape and we takes a positive cycle only. Let the time period of this wave is t. Let us divide this wave shape in n equal halves, having a time duration of t by n, equal time duration of t by n. Let I1, I2, I3 and so on, In be the mid ordinate of each section. The average value of this section would be, let it be the I1, I2, this section I3 and I. So what would be the heat developed by this current? That would be I square RT, I1 square R and time is T1 for this, I2 square R T by N and so on, In square R T by N. Heat produced by DC, steady state current. In a given resistance in a same time. I is the current, R is the resistance and total time is T and they would be same. Then this current would be the RMS value of this particular alternating quantity. I1 square by plus I2 square, In square by N RT, or this I square would be equal to, or I would be I12 plus In square, means these are the square values and mean of this square under the root is the RMS value. What its name indicates, RMS, mean of the square under the root. So generally in our AC system, our wave shape is of sinusoidal nature. So let us observe what would be the RMS value in case of the alternating one. Let us consider an alternating quantity, let this be the for the current I. and this will be the wave shape of scared wave. And negative half cycle, square of minus each plus. So let us, what will be the RMS value? Mean of the square under the root means area under the curve of the squared wave divided by base length. What is the RMS value for sine wave? Area under the curve of squared wave of one cycle divided by base length of one cycle. So first we will find out the area under the, what is the base length of the one cycle? Simply 2 pi minus 0, it is 2 pi. And what will be the area under the curve? To find the area under the curve, let us cut a strip in the squared wave of thickness d theta. D theta is the thickness of the strip, and I be the mid ordinate of this. Sorry, I square be the mid ordinate of the strip. So area of the strip is I square d theta. Now area of the full cycle is zero to 2 pi I square d theta, or base length pi. What will be the RMS value of the current? Zero to 2 pi I square d theta divided by 2 pi under the root O. Mean of the squared wave divided under the root is the RMS. We know what is I? I is Im sine of omega t, or Im sine of theta, and theta is omega t, or zero to 2 pi Im square sine square theta d theta by 2 pi, or Im square by 2 pi 0 to 2 pi 1 minus cos of 2 theta by 2 d theta, because sine square theta is cos 2 theta is 1 minus 2 sine square theta. Now integrate it. Im square 2 pi or 4 pi integration of 1 theta, integration of cos 2 theta is cos theta sin theta by 2, 0 to 2 pi. Sin 2 pi 0, sin 0 0. So it means this would be Im square 4 pi into 2 pi, or IRMS is Im by root 2, or 707 of the maximum. So maximum value of the RMS value of the alternating quantity is 0.707 of the maximum value. Similarly, VRMS Vm by root 2, 7 of Vm. This is the important relation by which you can correlate between maximum value and RMS value of the alternating quantity. Means RMS value is 0.707 of the maximum value. Next important term is average value. Generally denoted by I average, V average, or E average. So your average value of the alternating quantity is that steady state current which transfers same charge in a given circuit in same time as produced by the alternating current. And your average value in case of non-sinusoidal wave shape, let this one with the I1, I2, I3, In, and time period is T, and this current is divided into n equal halves. So what will be the average value? I1 plus I2 plus In divided by simple arithmetic mean of the all the quantities in the given cycle. If we have the sinusoidal wave shape, for example, our alternating wave shape is of this nature. That is, this is the wave shape for current. What would be the average value of this wave shape? Area under the curve for the cycle divided by base length. Now average value for a complete cycle would be 0. But alternating quantities can't be 0. Then, so we will take the half cycle for consideration. Average value of this half cycle and average value of this half cycle would be same, but there is only the change is positive half cycle, negative half cycle. So to find out the average value in place of full cycle, we will consider only half cycle. So here for sine wave, average value is area under the curve of half cycle divided by base length of half cycle. Similarly, area can be found out by considering a thickness d theta whose mid ordinate is given by I. So what would be the area of the strip? Now here, what would be the average value of the current? Area under the curve 0 to pi I d theta, and what would be the thickness? Sorry, base length pi, or 1 by pi 0 to pi. What is I? I am sine of omega t or sine of theta. Theta d theta, or I am by pi integration of sine theta minus cos of theta 0 to pi, or I am by pi minus cos of pi cos of 0. Or I am by pi, what is cos of pi? Minus 1, cos of 0 minus 1. So this would be 2 Im by pi. So what would be the maximum value? Sorry, average value of the alternating quantity of the whole average value of the sinusoidal wave shape I average would be equal to 2 Im by pi, or 0.0637 of the maximum value. Similarly, for voltage, average value of the voltage 2 Vm by pi, or of Vm. So this would be the average value, means average value is 0.637 of the maximum value of the alternating quantity. We have some more terms. Form factor. Noted by KF, and this is the form factor is ratio of RMS value to average value. And in case of sinusoidal wave shape, what is the RMS value? RMS value is 0.707 of the maximum value. And average value is 0.637 of the maximum value in case of sinusoidal wave shape. and it will be 1.1. So for sinusoidal or alternating voltage and current, form factor would be 1.1. Using this form factor, we can find out the RMS value from the maximum value, or we can find out average value from the maximum value. Another term is amplitude factor, peak factor, that may be named as crest factor, crest or peak or amplitude factor. Denoted by KD. So KA. And this is the ratio of maximum value to average value. Sorry, maximum value to RMS value. This one is important because generally high voltage testing or insulation testing is done on the basis of maximum strength of that particular cable, or for example for current and R 0.707 of maximum value, and it would be comes out to be 1.414. So for sine wave of voltage or current, crest factor is given by 1.414. So this is the basic terms which are being used in the alternating quantity. Whether we have the RMS value, whether we have the average value, whether we have the instantaneous value, we have the time period, we have the frequency, we have the amplitude. All terms would be used in the alternating.